Hello everyone, welcome back to the channel. I am Nikhil Kumar. In the last three videos, we saw how Kubernetes uses three types of props. Liveness prop to detect when a container is dead, readiness prop to check if it is ready for traffic, and startup prop to give slow apps a chance to initialize. But here's the thing, in real world application, these three don't work in isolation. They work together to keep your app stable. So today we will take a real world use case and machine learning inference service that loads a large model, and we will see how prop tuning can make or break your deployment. So before we jump into the live demo, let's quickly visualize what happens under the hood in Kubernetes. So whenever user's request comes in, it first hits the Kubernetes service. Think of this as a smart traffic controller that route requests to your pods. Inside the pod, your actual container, like your Python-based machine learning model, is running. And here's where the things get tricky. Your container may start instantly, but the machine learning model inside might take 30 to 60 seconds to load. So Kubernetes doesn't know that. It just sees no response and assumes the app has crashed. That's where these three props comes to the rescue. First comes the startup prop. This prop checks whether your app has actually booted up or not. It's asking, hey, have you even started yet? And once it passes, Kubernetes knows to stop restarting your pod unnecessarily. Then the readiness props comes in. This one checks if your app is ready to handle the traffic or not. So even if it's alive, Kubernetes won't send users to it until it gives the screen signal that I am ready. And finally, the liveness prop. It ensures your application remains healthy after it starts. If something goes wrong later, Kubernetes restart it automatically. That's a self-healing in action. So as you can see, these three props, startup, readiness, and the liveness props, form the perfect health system for your pods. Now that you have understood why props matter, let's jump into how to configure them in the Kubernetes. To simulate this, I will use a simple FastAPI app that behaves like a real machine learning model loader. It will take 60 seconds to load, and we will watch how these three props work together to protect it. So let's start by creating our application file. So this is my Kubernetes cluster. So inside this, I've already created a file that is app.py. So this is our simple FastAPI code. So let's understand what's happening here. At first, we import the FastAPI library, our lightweight framework for building APIs. Then we are using a flag that is ready to track when the model is loaded. Then inside the startup event, we simulate loading a large machine learning model using a sleep time that is for 60 seconds. In real life, this could be your TensorFlow or the PyTorch loading weights into your memory. And once it's done, we set is ready to true. So then the health set endpoint returns the app readiness. So it's returning 503 until the model is fully loaded. Once the timeout got completed to 60 seconds and the flag got updated to true, it start returning OK. That means our application or model got loaded. So these small applications mimic a very real world machine learning startup delay scenario. Now let's containerize this app because Kubernetes run everything inside a container. We will build a container file to build the image, then we will use it in our pod. So let me save and exit. So for that, we need to create a container file. So I've already created a container file as well. So this is our container file. So let's understand this very quickly. So at first, we are importing a base image that uses a minimal Python image. Then we are setting up our working directory. And here we are copying our source code inside the container using the copy command. And then we are installing the dependencies. And at last, we are starting our application using UVCon on port number 8000. This image will be the base for our Kubernetes pod. Let me save and exit and then build an image. Podman build -t image name. So I'm using my query repository here and giving a tag ML and then giving a dot notation because our container file located into the same directory. Now it start building a container image. So it's installing the dependencies. And once the dependency got added, it will successfully tag that image with the name which we provided in the command. We can reference this image into a Kubernetes manifest file. Now comes the main part, the Kubernetes manifest that defines all the three props. So let me open the file that is ml-props.yml. So this is our pod definition file. So till here, you already aware like how to define a pod. If you have watched my Kubernetes in pod video, below that in a last video, we covered the startup prop. So this is the same structure. So here it checks the /health endpoint after every 5 seconds and allows 15 failures. That's 75 seconds total. It's enough time for our 60-second model load. Then we have a readiness prop. It starts checking after 70 seconds to ensure the app is truly ready before getting a traffic. At last, we have a liveness prop. It begins after 90 seconds and keeps running to detect any post-startup issues. This configuration pattern is perfect for workloads where startup takes longer than readiness, like machine learning, data analytics, or heavy backend application. So now our manifest file is ready. Let's deploy and observe how it behaves. So let me save and exit and run the kubectl apply -f ml props.yml. The pod got created. So let's run kubectl get pods with -w option, that is watch. I think I missed one step, that is to push an image to the repository. Right now it's present locally, so I need to push it to the query repository. So let me cancel this. As you can see, it throws an error, that is image pull back off or error image pull. And if we describe this, so kubectl describe pod, and in the event section, we can get the error message. So it's not able to pull an image because it's not available on our query repository as of now. And if we check on our query repository, this is our query repository. We don't have any image as of now here. We have only one, that is v1, but not with the ML tag. So let me push it very quickly. So podman push and the image name. So let me log in this podman login query.io and let me enter the credential. Now let's run the same command. So this time it will work and push the image to the query repository. So our pod will work. Let me delete this kubectl delete -f ml props.yml. The pod got deleted. Let's verify that the image got pushed to the query repository or not. As we can see, the image got pushed a few seconds ago. Let me run the kubectl create command again. So kubectl apply -f and the manifest file name. The pod got deployed. So kubectl get pod with a watch option. So this time it's running, but as you can see, it's not ready as of now because it's still loading the model because we have added the 60-second sleep over there to simulate the loading of the model. During this phase, the startup prop keeps giving it time to boot up. And once the model is loaded, the readiness prop passes, marking it ready, and the Kubernetes starts routing traffic safely. And now it started working. And after that, the liveness prop keeps running in the background to ensure continuous health check. So that's it for today. By tuning your startup readiness and the liveness prop properly, you can make even slow loading machine learning apps stable and production ready. Remember, props aren't just health checks. They are the foundation of application resilience in Kubernetes. And if you haven't watched the previous videos explaining each prop individually, check them out below for a deeper understanding. If this video helped you, don't forget to like, subscribe, and share it with your friends. Thanks for watching. I will see you in the next one.